Hello everyone! Welcome to my presentation about black hole. On this topic, we will be talking about the introduction to black hole, the definition of a black hole, the types of black holes, the parts of black holes, and the term we call spaghettification. So please bear with me until the end of this video so that you can learn all about black holes. Black holes are among the most fascinating objects in our universe and also the most mysterious. The first time the idea of a black hole was suggested in the late 1790s by John Michael of England and Pierre-Simon Laplace of France. They both proposed the idea of the existence of an invisible star by applying the Newton law, and they calculated its mass and size, which is now called the event horizon that an object would need in order to be faster than even the speed of light. Later in 1915, Einstein predicted the existence of black holes with his general relativity theory. After that, in 1697 by John Wheeler, an American theoretical physicist, applied the term of black holes to what it means now. So, what are black holes? A black hole is a great amount of matter packed in a very small area. It is a place in space which has such a big gravitational field that nothing, not even light, can escape. Scientists can directly observe black holes, and the only way to perceive them is by detecting their effect on other matter nearby. As the attracted matter accelerates and heats up, it emits X-rays that radiate into space, and emitting powerful gamma rays burst which devour nearby stars. According to Hubble's site, NASA, a black hole is a region of space packed with so much matter that its own gravity prevents anything from escaping even a ray of light. Although we can see a black hole, the material around it is visible. Material falling into a black hole forms a disk similar to a whirlpool in a bathtub drain, and the matter swirling around a black hole heats up and emits radiation that can be detected. Around a stellar black hole, this matter is composed of gas, and around a supermassive black hole in the center of the galaxy, the swirling disk is made not only of gas but also of stars. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. The different types of black holes is stellar, supermassive, intermediate, and miniature. So, these are the types of black holes and how are they formed. The first we will talk about is the stellar black holes. One way black holes are created is from dying stars. Inside a star, the nuclear fuel of a star and its own gravity collide. This creates stability, but when it runs out of nuclear fuel, gravity compresses the star. The outer layers explode into a supernova, and the center implodes or collapses inwardly, and after that, a black hole is created. This only occurs in big stars which are at least 10 times bigger than the Sun.
Cygnus X1 is an example of a stellar mass black hole. And this black hole, commonly known as B616, is currently thought to be the closest black hole to Earth.
Then the second type of black holes we'll be talking about is the intermediate mass black holes. The intermediate mass black holes is, as the names implies, intermediate black holes fall between stellar mass black holes and supermassive black holes. This type of black hole is not too small or not too big, but it's rare. Intermediate mass black holes are thought to form when multiple stellar mass black holes undergo a series of mergers with one another. These mergers frequently happen in crowded areas of galaxies. Merging stellar mass black holes spend a very long time in the early stages of their mating dance, but eventually they zip around each other faster and faster until finally coming together and forming a single larger black hole.
HLX-1 is an example of an intermediate black hole.
And the next one, or the third one, is the supermassive black holes. Black holes tend to grow larger and larger through mergers. And that's expected to be the case for supermassive black holes too. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our Sun. They exist at the center of just about every large galaxy like Andromeda Galaxy and even including our own Milky Way galaxy. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our Sun. Although there are many theories about how this type of black hole forms, but one of the most compelling is that they grow so large through a runaway chain reaction of colliding stars and black holes. So in this scenario, the seed of the supermassive black hole continually merges and gobbles up more and more material, eventually getting so massive that it sinks toward the center of its galaxy.
TON 618 is the largest supermassive black hole known, and the list of most massive black holes in the table.
So, the last type of black hole is the miniature black holes. This type of black holes have event horizons as small as atomic particles. Physicists suggest that these were created during the Big Bang. Miniature black holes were created more than 10 billion years ago and they compressed into a really small point which later exploded and created a massive explosion. So, according to its physical properties of the different types of black holes, first is the Schwarzschild black hole, which has no charge or rotation, the simplest type of black hole that exists. Next is the Reissner-Nordstrom black hole, which does not rotate but which has electrical charge. Then next is the Kerr-Newman black hole, which has charge and rotates, and the Kerr black hole, which rotates and does not have charge inside. The most commonly known way of a black hole forms is by stellar death. As stars reach the ends of their lives, most will inflate, lose mass, and then cool to form white dwarfs. But the largest of these fairy bodies, those at least 10 to 20 times as massive as our own Sun, are destined to become either superdense neutron stars or so-called stellar mass black holes. So now, let's explore the different parts of a black hole. So the first we are going to explore is the singularity. The center of a black hole is where all its mass can be found. This specific location is called the singularity. At this point, matter collapses into a region of infinite density. Sometimes a black hole rotates, creating a ring of singularity rather than one point. Next is the event horizon. The black hole found around a singularity is called the event horizon. At this distance, matter and energy cannot escape the gravity or pull of the black hole. Any objects that fall into its path and pass the event horizon will be pulled into the black hole. Next is the photon sphere. A photon sphere is a region where gravity is so strong that photons are forced to travel in orbits. A photon is a particle of light. Normally, light travels in waves, but not when it is near or inside a black hole. A rotating black hole has two photon spheres. Next is the relativistic jets. When a black hole absorbs objects like stars, gases, and dust particles, it can produce jets of plasma and radiation that blast outward from the black hole's poles. These jets can travel almost as fast as the speed of light and can be thousands of light years. Next is the innermost stable orbit. The inner edge of an accretion disk is the last place that material can orbit safely without the risk of failing past the point of no return. Then we have the accretion disk. An accretion disk is a rotating disk of matter formed by material orbiting around a black hole. This disk whirls around a black hole at immense speeds and produces electromagnetic radiation like X-rays. It can be used to reveal the black hole's location. The Schwarzschild radius. This is the event horizon's radius. It is the radius at which the escape velocity is equal to the speed of light. It's the event horizon radius. Its formula is R equals 2gmc squared. Lastly, we have the jets of gas. In some black holes, there is such a high intensity that magnetic fields are emitted perpendicular to the accretion disk. Due to this, same charged particles have to go around the black hole because it is in a magnetic field. So, black holes are points in space that are so dense that they create deep gravity sinks beyond a certain region that even light can escape the powerful tug of a black hole's gravity. And anything that ventures too close, can be it a star, a planet, or spacecraft, will be stretched and compressed like put in a theoretical process aptly known as spaghettification.
This is when astronomers watch a star get spaghettified by a black hole.
So you are confused with the term spaghettification, right? So, spaghettification in astrophysics, this term refers to the effect of a black hole imposes on a body or matter. The term was proposed by Stephen Hawking in his book A Brief History of Time, where he compared this effect to spaghettis, saying that you are stretched and you turn so thin that you break apart and transform into matter.
Interesting facts. If you fell into a black hole, theory has long suggested that gravity would stretch you out like spaghetti, though your death would come before you reach the singularity. But a 2012 study published in the journal Nature suggested that quantum effects would cause the event horizon to act much like a wall of fire, which would instantly burn you to death. More facts. Did you know that black holes don't suck? Suction is caused by pulling something into a vacuum, which the massive black hole definitely is not. Instead, objects fall into them just as they fall toward anything that exerts gravity, like the Earth. Next is that the first object considered to be a black hole is Cygnus X1. Cygnus X1 was the subject of a 1974 friendly wager between Stephen Hawking and fellow physicist Kip Thorne, with Hawking betting that the source was not a black hole. In 1990, Hawking conceded defeat. Next, if a star passes too close to a black hole, the star can be torn apart. And fact 5 is that astronomers estimate that the Milky Way has anywhere from 10 million to 1 billion stellar black holes with masses roughly 3 times that of the Sun. Lastly, black holes are the ultimate energy factories. Black holes can generate energy more efficiently than our Sun. So that is the end of my presentation. Thank you for listening, and if you have any questions, please don't forget to contact me and reserve your questions to the Q&A in Wednesday. Thank you.